Hello everyone and welcome to iLand Technologies presentation, and today we'll be looking at 802.11ax Wi-Fi and its benefits as well as its support in Draitech products. My name's Darren and I'm the Queensland sales rep at Draitech Australia and New Zealand. I'll start by looking at what 802.11ax is, then we'll look at the different components that make it up, the benefits that it brings, and finally we'll go through some Draitech products available that feature 802.11ax. If you have any questions during the video, please comment in the chat box over on the right side of the screen and stick around at the end for a 5-minute Q&A session. Don't forget you can pause the video or skip back anytime if you'd like a longer look at anything or to hear it again. If you're watching this after the live premiere, please comment below or send an email to sales@draitech.com.au. So let's start by looking at what 802.11ax is. Wi-Fi standards today are based on the 802.11 specifications created by the IEEE committee back in 1997. As Wi-Fi technology developed through the years and network bandwidth gradually increased, letters were added to reflect the improvements. So now we have 802.11b, .11a, .11g, .11n, .11ac, and the latest one is 802.11ax. The table here shows the different 802.11 Wi-Fi standards along with the frequency of bands being used. The Wi-Fi naming convention has been changed recently so that it starts with Wi-Fi 1 for the earliest Wi-Fi standard to Wi-Fi 6 for the latest. So the highest number indicates the latest standard. At the bottom of the table we can see that Wi-Fi 6 equates to the 802.11ax standard. 802.11ax has several advantages, including improved data rates and efficiency. Draitech has released a number of products using 802.11ax technology, and we'll take a look at those a little later. The table here has a comparison between 802.11ac and .11ax technologies. The main advantage of using 802.11ax is that it allows higher data rates when compared to 802.11ac, particularly in high-density environments where many people are trying to use the Wi-Fi network at the same time, such as in classrooms and conferences. Now that we've looked at what 802.11ax is, let's delve a bit deeper and look at the components that make 802.11ax better than its predecessors. As mentioned earlier, 802.11ax, otherwise known as Wi-Fi 6, can be used in high-density Wi-Fi applications. There are a number of parameters that are used to optimize the radio utilization. These are MU-MIMO, OFDMA, 1024 QAM, and BSS coloring. I'll go over each of these in more detail. Draitech 802.11ax devices utilize MU-MIMO technology. MU-MIMO is short for multi-user, multiple input, multiple output. What this means is that the access points can communicate with multiple devices simultaneously, leaving additional time and capacity for other Wi-Fi clients. This provides much greater capacity for the Wi-Fi network. It also works for both downlink and uplink Wi-Fi communication. When we compare this to SU-MIMO, that's single-user MIMO, we can see that only a single wireless device can communicate with the access point, so each data stream is handled sequentially, reducing capacity for Wi-Fi clients. As the number of wireless clients increases, users need to wait longer for their turn, which causes more packet loss, laggy video, and buffering. Here we have an illustration comparing single-user MIMO to multi-user MIMO. We can see that for single-user MIMO, the wireless router or access point can only service one client at a time, which can slow down communication if there are many clients requiring access. Comparing this to MU-MIMO, we can see multiple clients can upload and download data at the same time, thereby improving communication speeds. OFDMA is a key feature of 802.11ax. It's an abbreviation for Orthogonal Frequency Division Multiple Access, which is an advanced technology for sharing a radio carrier between many users at once. The access point's channel bandwidth is split up into small chunks referred to as resource units. Then it uses complex scheduling in the background to determine which users need more resources at any one time. With OFDM, each frame is transmitted across the entire channel width, so it's not as efficient as OFDMA. Here we have an illustration of the differences between OFDM and OFDMA. With OFDM technology, each frame is transmitted across the entire channel width. This results in a low rate of transmission for high density applications, resulting in latency and jitter, along with lower overall efficiency. However, with OFDMA, each Wi-Fi channel is split into tiny chunks, allowing multiple devices to transmit and receive simultaneously on the same channel. So basically, more devices will get more bandwidth simultaneously for a faster Wi-Fi network overall. So users watching streaming services can be allocated more bandwidth and time, while VoIP or just checking email could be assigned less, but just as much as each one requires to improve the wireless experience in high-density environments. On a more technical level, OFDMA splits a 20 MHz channel into 256 subcarriers. Those carriers are grouped into subchannels called resource units, or RUs, which differ in size and determine the transmission width allowed for use by a single client. You'll see the sizes of the RUs in the table here as RU26, RU52, and so on. The number indicates the number of subcarriers comprising a subchannel. For example, RU26 is a subchannel with 26 subcarriers. The width of RU26 is about 2 MHz, which means a 20 MHz bandwidth can serve about 9 Wi-Fi clients simultaneously if the transmitting data for each client is less than 2 MHz. The next component we'll look at is the modulation used in 802.11ax. The term used here is QAM or QAM. This is an abbreviation for Quadrature Amplitude Modulation, which is a modulation scheme used in transmitting data. QAM refers to a way of changing the amplitude or power level of two signals. The 1024 QAM used in 802.11ax enables a 25% data rate increase when compared to 802.11ac, which uses 256 QAM. This improvement is crucial for consistently serving a large number of wireless clients. 802.11ax also introduces a feature called BSS colouring. BSS stands for Basic Service Set. Some background information why we use BSS colouring. In wireless networks, only one radio at a time can transmit on the same channel at the same time to avoid interference. BSS colouring makes use of carrier sense multiple access with collision avoidance, or CSMA/CA, to detect and defer transmissions if a collision is detected. However, when too many access points and Wi-Fi clients hear each other on the same channel, it will cause co-channel interference, also called Overlapping Basic Service Set, or OBSS. This leads to airtime consumption and performance degradation. The use of BSS colouring helps to deal with the spatial frequency reuse problem in overlapping BSSs. As long as the overlapping channels are allocated different colours, APs and Wi-Fi clients can transmit even if hearing each other on the same channel. The BSS colour doesn't mean you'll be seeing colours somewhere, it's just a numerical identifier that is a 6-bit field in the packet header, which allows 802.11ax radios to differentiate BSSs with a colour identifier when other radios transmit on the same channel. The BSS colouring value determines whether transmissions are coming from their own network or another wireless network. In the 802.11ax management frame, we have the BSS color info byte, of which 6 bits defines the color, giving us 63 possible colors. The same color indicates an intra-BSS transmission, and the station will defer transmissions. A different color indicates an inter-BSS transmission, and the station will still transmit data. If an access point detects a color collision, it can change its BSS color. Color collisions are detected if an access point hears a transmission from an AP or client in a different BSS that has the same color. If the 802.11ax associated client hears an OBSS with the same color, it will automatically send a color collision report to its associated AP. The report will include BSS color information of all OBSSs that the client can detect. On detecting the color collision, the access point can change its BSS color, and it will inform all clients associated to it about a BSS color change with an action frame called BSS Color Change Announcement. The end result is that 802.11ax networks can safely overlap access points on the same channel. Okay, now that we've looked at the components that make up 802.11ax, let's look at some of the benefits. Listed here are some of the benefits of using 802.11ax in your network, which include speed improvement, increased access point and devices capacity, greater channel width, efficient bandwidth sharing, reduced latency and jitter, and importantly, backwards compatibility. Wi-Fi security is also enhanced in 802.11ax products. As we can see in this illustration, in the 2.4 GHz band, 802.11ax is 2.8 times faster than 802.11n, and for the 5 GHz band, 802.11ax is 3.2 times faster than 802.11ac. We should note that the speed is the total throughput of the access point with multiple client connections and not the throughput of a single client connection. As noted earlier, 802.11ax can be used in high-density wireless networks, such as in a classroom where many people are simultaneously accessing the wireless network. In this scenario, users should see minimal performance loss in Wi-Fi speeds. We talked about BSS colouring earlier. This feature allows overlapping channels to be allocated different colours, so more access points and wireless devices can share the same area without interfering with each other. In a typical workplace, an employee might have multiple wireless devices such as a PC, a mobile device, and a smart accessory, which can quickly add up to a large number of connected devices on a wireless network with many employees. This is in addition to attached office equipment or access points. The increased access point capacity of 802.11ax through the use of BSS colouring means that users will not see a performance drop or jitter or lag in wireless communication. 802.11ax can use a wireless channel width of up to 160 MHz. This, along with the higher modulation of 1024 QAM, and when combined with OFDMA, results in much greater wireless throughput in a Wi-Fi router or access point. As mentioned earlier, using 802.11ax devices will give you reduced latency and jitter, which is important in applications that involve live streaming of video and audio, such as in video conferencing. When combined with high-speed internet, it is possible to have video conferences using 4K Ultra HD video with no reduction in performance. OFDMA, which we discussed earlier, allows multiple users and devices to simultaneously communicate over the wireless network. This is through the efficient use of the wireless bandwidth through allocation of user time and data transfer scheduling. One of the benefits is that a single user carrying out a large file transfer or a download cannot impact the wireless performance of other users. One useful benefit is the 802.11ax standard is backwards compatible with older standards. What this means is that in a wireless network which has older devices running older standards such as 802.11ac, N, G, and A, these devices will still be able to communicate through 802.11ax routers and access points. It is still advisable to test older devices on your network for compatibility before deploying 802.11ax on your network though. Also keep in mind that if you're using an older device running an older wireless standard, such as 802.11b, you won't be able to fully experience the benefits of 802.11ax's features. The final benefit I'll mention is that 802.11ax also includes updates to wireless security, such as the WPA3 security standard, which uses 192-bit encryption instead of the 64 or 128-bit we got in WEP and WPA2. Okay, let's look at what Draitec products are available when it comes to 802.11ax. First, the routers. Draitec has 3 dual WAN 802.11ax routers. These are the VIGA 2865AX, the VIGA 2866AX, and the VIGA 2927AX. The 2865AX and 2866AX routers are VDSL2 compatible with one DSL port and an Ethernet WAN port, while the VIGA 2927AX router is a broadband router with 2 gigabit Ethernet WAN ports and no DSL port. These routers share the same wireless specification. The 2.4 GHz band has a channel bandwidth of 40 MHz with speeds up to 600 megabits per second, and is backwards compatible with older standards such as 802.11b, G, and N. The 5 GHz band can support a channel bandwidth of up to 160 MHz with speeds up to 2,400 megabits per second, and is backwards compatible with older wireless standards such as 802.11a, N, and AC. In the access point product range, Draitec have 2 802.11ax ceiling-mounted access points. The first one is the VIGA AP960C. It can be powered using PoE through the 1 gigabit LAN port, or it can be powered from an external 12-volt power adapter. Looking at the specifications, we can see that the 2.4 GHz band has a channel bandwidth of 40 MHz with speeds up to 600 megabits per second and is backwards compatible with older Wi-Fi standards, and the 5 GHz band can support a channel bandwidth up to 80 MHz with speeds up to 1200 megabits per second and is also backwards compatible with those older wireless standards. The next model is the VIGA AP1060C. This is an AX3600 ceiling mounted access point. It's slightly larger than the VIGA AP960C and it has a 2.5 gigabit LAN port. It also can be PoE powered or powered from an external 12 volt power adapter. Looking at the specifications, we can see a few differences to the VIGA AP960C. The 2.4 GHz band has a channel bandwidth of 40 MHz with speeds up to 1200 megabits per second with backwards compatibility for older standards, while the 5 GHz band can support a channel bandwidth of 160 MHz with speeds up to 2400 megabits per second. The VIGA AP1060C has a dedicated third radio that constantly monitors all channels for airtime availability and channel utilization. It displays the 3 best channels for the network administrator to select. Another useful feature in the VIGA AP1060C is constant monitoring of the network for rogue access points. When an AP broadcasts an SSID that has been assigned, the VIGA AP1060C will inform the network administrator. So to summarise, today we started by looking at what 802.11ax Wi-Fi is and the different components within it, as well as some of the benefits of using it. Then we looked at what Dratec products are available that support it. These included the VIGA 2865AX, the VIGA 2866AX, and the VIGA 2927AX routers, and the VIGA AP960C and 1060C ceiling mounted access points. Okay, that's all for now, but please stay tuned. We'll be answering questions in the live chat on the right of your screen for the next 5 minutes. If you'd like more information about Dratec products, please check out our website at www.dratec.com.au or email us at sales@dratec.com.au or just give us a call on 02 9838 8899. Please give us a like and subscribe below and give the bell a click if you'd like an alert whenever we put up a new video. Thanks and bye for now.